guys. So what we're going to look at today is a new type of function in the graph. If you were in Honors Algebra 2 last year, you probably saw these, but we all need to review them because these can be a little bit tricky. And this is something called a piecewise function. So what a piecewise function is, it's really pieces of different graphs that make one function in general. So what you'll see is for the notation kind of this one-sided curly brace, and then multiple equations on the inside. It could be 2, 3, it could be as many as it wants to be. But each of those functions is going to have a domain next to it. So the way we would read this is I would have a certain function with a certain domain. Then I'd have another function with another domain. And then I have another function with its own domain. So to start, we are just going to figure out how to evaluate these and kind of how to read it. Then we'll look at actually graphing them and writing the equations. So this first one, we're going to evaluate f of negative 4. So let's remember what that means. That means when x equals negative 4, what does y equal? So to figure out when x equals negative 4, we're going to look at our equation. Okay, I've got 3 different domains here, and I need to figure out which one negative 4 is going to fall in. Well, negative 4 is going to fall in the top domain, because when x is less than negative 2, that includes negative 4. Once we know which domain we're using, we're going to plug negative 4 into that equation. So 2 times negative 4 gives me negative 8. All right, same idea on the next one. F of negative 2 means when x equals negative 2, what does y equal? Well, in this case, again, there's 2 domains. 2 of them have negative 2 on it. But this first one says x is less than, not or equal to. The next one says x is greater than or equal to. Since that one has the or equal to, that's the one we're going to use. And in that case, there's not even an x to plug it into. It's just 4. All right, the next one, f of 0. So let's figure out which domain 0 falls in. 0 is not less than negative 2. 0 is not greater than or equal to 3. 0 falls in between negative 2 and 3. So we're going to use the second equation, so we get 4. All right, the next one, f of 3. So when x equals 3, then it's going to be the or equal to. So x is greater than or equal to, which is the bottom. So we're going to plug 3 in for x to the bottom equation. So negative 9 minus 7 is a negative 16. All right, then looking at the last one, again, figure out which domain to use. 5, when x equals 5. X equals 5 would fall in the domain x is greater than or equal to 3. So I'm going to plug in 5 to the bottom equation. So that's negative 15 minus 7, which is a negative 22. All right, this next one, this is an example of what a piecewise function graph is going to look like. And we are going to go ahead and plot one of these here in a little bit. But again, we're just going to evaluate very similar to what we did previously. So f of negative 1 means when x equals negative 1 on the graph, what's y? So I go to negative 1 on my graph, and the y value there is 0. F of 2 means when x equals 2, what does y equal? When x equals 2, y is 1. Now when we do f of 1, though, it's a little bit harder, because you'll notice there's 2 points on my graph. There's an open circle and a closed circle. Remember, the closed circle is the actual point we're going to use. So the y value of the filled-in circle is 1. All right, let's look at negative 2. Same thing. When x is negative 2, there's 2 values. We're going to use the filled-in circle, which is negative 1. And then finally, we've got f of 0. So when x equals 0, we find that on the graph. The y value there is 1. All right, now let's go ahead and actually sketch one of these graphs. So this first one has 2 equations. So what we're going to do, what I usually do first is I plot the border point, okay? So basically whatever this number is, I'm going to plug that value in first. So I'm going to take negative 1 and I'm going to plug it in for x into this first equation. So if I plug in negative 1, 2 times negative 1 minus 1. That's going to be negative 2 minus 3, which is negative 3. So that means that negative 1, negative 3 is going to be the border point. It's the end point, basically, of this first graph. Now I need to figure out if it's an open circle or a filled-in circle. Because it was x is less than or equal to, it's going to be a filled-in circle. So at negative 1, negative 3, I'm going to plot a filled in circle. Then I'm going to plot the rest of this graph. So how you do that is dependent on how comfortable you are with these graphs. Okay? When x is less than or equal to -1, that's going to be everything to the left of -1. Everything to the left is the line 2x minus 1. So there's two ways you could do this. You could take more x values and plug in more x values. So I could plug in -2. I could do 2 times -2 minus 1 and get -5 and plot the point -2, -5. All right, I could plug in -3 and get another point. But you know if it's 2x minus 1 that it's a line. So once you have another point, that gives you the line. You also didn't have to plug in that value if you knew, hey, this is a line with a slope of 2. Since I'm going to go to the left, I'm just going to have a slope of 2 to the left. All right, now let's go ahead and do the right side of this graph. Okay, so again, I'm going to start by plugging in the endpoint. So I'm going to take -1 and I'm going to plug that in for x. So a -1 plus 3. So that's going to be 1 plus 3, which is 4. So -1, 4 is going to be on this graph. It's an endpoint for the right part. Okay, again, this is the right part because its x is greater than -1. So this is not or equal to, so it's going to be an open circle. So at -1, 4, I'm going to plot an open circle. Then everything to the right is the line -x plus 3. So if I want, I can graph that line. It has a y-intercept of 3 and a slope of -1. If I'm not sure what it looks like, pick more x values and plug them in. I could plug in 0 and get 0, 3. I could plug in 1 and get 1, 2. And I'm getting the same coordinates that I plotted that same way. All right, now let's look at one that has 3 domains on it. All right, so again, I'm going to start with that endpoint. So I'm going to take -2 and I'm going to plug it in for x. So if I plug in -2 for x, 1/2 times -2 is -1. This was not or equal to, so it's going to be an open circle. So at -2, -1, I'm going to plot an open circle. Everything left of that point is the line 1/2 x. So it's going to have a slope of 1/2. Or again, I could pick more x values and plug them in as well. But I'm just going to go ahead and have a slope of 1/2 and continue in that direction. All right, now let's do the middle one. Okay, the middle one, you'll notice there are no x's. That's just because it's a horizontal line. Okay, but again, let's plot our endpoints. When I plug in -2, I get -1. So -2, -1 is going to be on that graph. It's or equal to, so it's going to be a filled-in circle. So at -2, -1, I'm going to have a filled-in circle. Now, if you notice, there's already an open circle there. That's okay. The filled-in circle will take the place of the open circle. So we just have a filled-in circle there now. All right, everything else up until 3 is going to have a y value of -1. So I'd have a point here, 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 here. Then at 3, -1, I'm going to have an open circle because it's not or equal to. And then I'll go ahead and connect it. And then finally, we'll look at this last endpoint. I'm going to plug in 3. So -2 times 3 is -6. -6 plus 3 is -3. So 3 and -3 is the endpoint for the last section of my graph. 3 and -3 is going to be a filled-in circle. Then everything to the right is going to be this line -2x plus 3. So everything to the right is going to have a slope of -2. And that's my graph. Now, another thing you can do here, if you're more comfortable, if you want to actually just plot the line -2x plus 3, you can, and you can just erase the part that's not actually on your graph. That's another strategy that you can use to actually draw this. All right, let's look at a couple more. So this next one, okay, if you feel comfortable, pause the video, try this one on your own. All right, so let's plug in -1. All right, so -1 minus 2 is -3. This is going to be an open circle. And then everything to the left is the line x minus 2. So again, if we don't know what that looks like, pick different x values to plug in. Plug in -2. plug in -3, plug in -4 to get more points. But I know the slope is 1, so I'm just going to plot it this way. Then on the next one, if I plug in -1, well, there's no x to plug in. The y is just going to be -3. So I'm going to do a filled in circle, which is going to fill in the circle I already have. And then everything to the right is going to have that same y value. Okay, every x to the right has a y value of -3. All right, the last one, a little bit tricky. This one has 3 areas. It also has a quadratic on it. So let's go ahead and start with the first one. Okay, I'm going to start with the first endpoint. I'm going to take -3 and plug it in for x in that first equation. So if I plug in -3, that would be 1/3 times -3 is -1. -1 plus 2 is 1. So -3, 1 is going to be a filled in circle because it's or equal to. Then everything to the left has a slope of 1/3. So down 1 and left 3. And again, if you're not sure, take an x value, plug it in. All right, now let's do our middle section. I'm going to plug in the endpoints, so -3. So if I do a -3 minus 2, that's going to be 3 minus 2, which is 1. So -3, 1 is an open circle. Well, there already is a point at -3, 1. It's already filled in. That's okay. All right, let's do the other endpoint. If I plug in 0, okay, 0 minus 2 is -2. That's going to be an open circle as well because it's not or equal to. So open circle here. Everything in between those, it is a line. It's the line -x minus 2. Y-intercept of -2, slope of -1. So just connecting those points with a line makes that pretty easy to see. All right, now let's look at the last one. This one's a quadratic. So if we don't remember what it looks like, let's plug in points. Again, let's start with 0. If I plug in 0, 0 minus 2 is -2. Filled in circle because it's or equal to. And again, it overlaps. Now, these won't always overlap, okay? But I wanted you guys to see a few examples of those just because it does happen sometimes. So we fill it in, and it's going to be a quadratic to the right. To get some more points, let's plug in some x's if we don't remember how to graph this quadratic. Okay, I'm going to plug in 1. 1 squared minus 2 is -1. Let's plug in another point, 2. 2 squared minus 2, that's 4 minus 2, that's 2. So that gives us a little bit of a better picture of what that quadratic is going to look like. So again, if you don't remember how to graph one of these, just pick some x values and plug them in and see what y value you get as a result. So the last thing we're going to do is we're going to work backwards. Okay, we're going to write the piecewise function. So really, this is just remembering how to write the equation of a line and also writing domain. Okay, so notation here, it's f of x equals, and then we do just one of those little curly braces. So the first thing I'm going to do is I'm going to write the equation of this first line. Okay, so that first line, let's find the slope and the y-intercept. So the slope of that line, up 1 over 2. So that line has a slope of -1/2. The y-intercept of that line is 1. Then what we do is we write the domain of that line. Well, that domain would be when x is less than 2. It's not or equal to because it's an open circle. All right, now let's write the equation of the right side. So the right side would be this line over here. It's a line, so let's get the slope and the y-intercept. Well, up 1 over 1, the slope is 1, and I don't see the y-intercept. So I can either solve for it algebraically, or I could just continue that same slope and see where it crosses the y-axis. And it crosses at -1. Now let's write the domain. So I need my x's to be greater than or equal to. It does have to be or equal to because it's a filled-in circle. It's greater than because it's going to the right, and the x value is 2. All right, let's try one more of those. If you feel comfortable, pause the video, try this one. This one's a little bit tricky because it does have 3 sections to it. So the first line is just the line y equals 3. All right, because it's a horizontal line and all the y coordinates are 3. Then we write the domain. X is less than, not or equal to, because it's an open circle, -1. Then we write the middle. So the middle parabola is a quadratic, okay? So let's look at the transformations here. This is a quadratic that shifted up 1. So the way we would write that is x squared plus 1. Then we're going to write the domain. The domain, x is in between -1 and 2. It's not equal at 2, it's an open circle, but it is or equal to at -1. Then we'll write the equation of the last line. All right, so it's a line, so we need the slope. The slope is -1. To get the y-intercept, let's just continue that pattern. It goes up to 4. And then I get that x for my domain is greater than or equal to, because it's a filled-in circle, and it's the x value of 2. All right, so for those of you guys who are planning on taking calculus, I will tell you piecewise functions do come up a lot there. So it's really important that you understand how to read them and what they're saying. We'll see these kind of come up throughout the year as well, so you guys can get some more practice with them then.